Welcome to the third unit of our pagination course. By now, you're well versed in studying API documentation and implementing API calls with paginated data. In this unit, we'll explore a particularly challenging aspect, handling API calls when the number of repetitions isn't predefined. This skill is crucial to ensure that you capture all necessary data without overlooking any details or processing empty bundles. Let's dive in and explore the strategies to tackle this efficiently. Let's delve into the concept of variables, a crucial component in programming and scripting. Variables act as placeholders to store and manage data, allowing you to manipulate information more efficiently. Imagine them as labeled containers where you keep your data neatly organized, ready for use whenever needed. In the context of API calls and paginated data, setting the initial URL as a variable is particularly important. It allows you to dynamically change the URL parameters without altering the core of your code. This flexibility is vital for handling scenarios where the number of data bundles isn't predetermined. As you explore how to set multiple variables, remember that each variable can be tailored to suit specific needs, from managing URLs to tracking page numbers in a series. This adaptability not only streamlines your process, but also ensures you capture all necessary data without missing out or creating excess loads. Let's take a closer look at how to effectively implement these concepts. Imagine you're packing for a big move. You fill boxes with items like toys, books, and shoes and label each box so you know what's inside. Variables in programming serve a similar purpose. They act as containers for storing data, each marked with a unique name that helps identify its contents. Think of a variable as a labeled box, holding one specific piece of data. This name is fixed, but the value inside can change. Just like replacing the contents of a box, you can update what's stored in a variable whenever needed. In programming scenarios, variables make data easily accessible, allowing you to reuse it multiple times. They also simplify complex actions, streamlining processes, and enabling efficient updates. As you dive deeper into programming, mastering the use of variables will help you organize and manage data effectively. In programming, every variable you create is like giving a special name tag to a container where your data is stored. Once you have a variable, you use specific tools to assign it a value. Let's focus on how you can do this effectively. To give a variable a value, you can use modules called set a variable or set multiple variables. The essentials here are to specify the exact name of your variable and the value you want it to hold. It's kind of like labeling a box and placing something inside it. Remember, variables are flexible. The data inside isn't locked in forever. You can change it whenever you need by assigning a new value to your variable using the same tools. A crucial tip: always use identical spelling, including capital letters and spaces, when naming and retrieving your variables. Missteps here can lead to frustration, as it might prevent you from accessing your data correctly. For best practices, try avoiding spaces in variable names. Instead, consider alternatives like using hyphens, camel case, or underscores. This small habit can make a big difference in keeping your data organized and easily accessible. Let's explore how you can use variables more effectively in your scenarios. Once you've assigned a value to a variable, you can use that value in other parts of your workflow by mapping it into subsequent modules. This allows you to reuse data without redefining it. It's important to remember, though, that variables are scoped to the specific scenario you're working in. This means you can only use them within that scenario and not directly in different routes. If you need to access a variable elsewhere, you'll have to use the getVariable module. Make sure you use the exact name of the variable, following the same capitalization and spacing rules as when you created it. This precision ensures that the system retrieves the correct value for use in other modules. By understanding these principles, you can maintain data consistency and streamline your processes across your scenarios. Understanding the lifetime of a variable is crucial in programming. In our context, a variable's lifetime can either be limited to one cycle or to one execution. When we say one cycle, it means the variable retains its value only during that single iteration of the process. It's like a temporary note that you use and then discard after each task is complete. On the other hand, one execution refers to the entire process run. Here, the variable's value is maintained throughout the process until the execution ends. This distinction is important because it determines how and when you can access your data. Remember, within a scenario, a variable is accessible only in the context where it was first set. Understanding these details ensures you're effectively managing your data throughout your programming tasks. In this scenario, we revisit Philip's process for using an API to gather images from pixels and email them to customers. Previously, you utilized page numbers to handle image retrieval. Now we're shifting to a more dynamic method using the next page URL. This approach enhances the flexibility and efficiency of your API calls, allowing you to seamlessly fetch data using the URLs provided by the API response itself. By leveraging this technique, you're aligning closely with modern API practices that facilitate easier data navigation and retrieval. If you need a brief refresher on the initial API setup, feel free to revisit the prior unit. Otherwise, get ready to dive deeper into planning your new API call, where we'll focus on integrating these URLs effectively into your workflow. Now that you're ready to plan your API call, let's delve into the process more deeply. Imagine that the total number of hits isn't provided up front. Instead, you'll rely on the next URL to guide your API call planning. This scenario will help you understand how to manage actual API responses dynamically. First, remember that the initial API call structure is determined by the documentation and the next URL given in the response. Your task is to figure out how to extract this next URL and integrate it smoothly into your subsequent calls. You'll use a next page variable for storing and passing this URL information. This allows your application to navigate from one page of data to the next efficiently. To achieve this, consider three crucial questions. How will you pass the URL to the HTTP module properly? What strategy will you use to map the next URL in sequential API calls? And finally, what is the best way to define the initial URL for your first request? These questions will guide your thought process and ensure that your API calls are robust and responsive to real-world conditions. To effectively manage API calls, it's crucial to set up a dynamic URL mapping strategy. Begin by using an HTTP module that can handle both the initial and subsequent requests seamlessly. Here you'll map a variable called page_URL. This variable is essential because it starts by holding the first URL needed to kick off the process. As you receive responses, it will adapt by updating with the next page URL for the following calls. This process relies on a getVariable module, which ensures continuity in your data retrieval. By anchoring the initial call with the first URL and allowing the system to dynamically switch to the next URL, you create a loop that efficiently handles data pagination. This approach not only streamlines your workflow but also enhances the robustness of your API interaction, adapting to changing data streams as they become available. Now, we're exploring how to calculate the number of times you'll need to repeat an API call when you don't know the total number of results. Essentially, the goal is to ensure we're retrieving all available data without submitting unnecessary or empty requests. First, focus on retrieving all items. This means making sure your API call is set up to gather every data point available from the endpoint. It's important to inspect the structure of the API response carefully to identify how data is paginated or segmented. Next, avoid processing empty bundles. This means checking the response from each call to confirm there's actually data to work with before proceeding. By doing this, you prevent your system from wasting resources on unnecessary operations. Together, these strategies help maintain an efficient process, even when you're working with dynamic or unknown data sets. When defining the number of repetitions in a process, it's crucial to establish clear parameters. The initial value sets the starting point, typically at 1. This ensures your process begins in a consistent manner each time. The number of repeats, in this instance set to 40, provides flexibility to capture all necessary data without overwhelming your system with excessive pages, always keeping this number below the 10,000 mark. Finally, the step value, which is typically 1, dictates the increment for each cycle. By thoughtfully setting these parameters, you can efficiently manage data retrieval, balancing thoroughness with system performance. Keep in mind, setting a reasonable upper limit prevents processing inefficiencies and maintains operational control. As you work with data retrieval, it's important to understand how setting a fixed number of repetitions can impact your process. In this example, you're retrieving data, but only a portion of the generated bundles actually contain useful information. Typically, you might only need about 4 bundles, yet the system might produce many more, often resulting in dozens of empty bundles. These empty bundles can slow down operations and waste valuable time. Unfortunately, once the repeater is set to a specific number of repeats, it will produce that many bundles regardless of whether they are needed or not. This can be frustrating as you watch resources being used on processing these unnecessary bundles. However, there's no need to worry too much about this inefficiency. A workaround exists to better manage how bundles are processed, ensuring only the essential ones are handled, saving both time and resources. To effectively manage the retrieval of data with pagination, it's crucial to leverage the concept of a next page indication from the API response. This approach ensures that you only make necessary repetitions and avoid processing empty bundles. Here's how it works. When a page of data is successfully retrieved, the API response will include an indicator for the next page. However, once the last page is reached, this next page indicator will be absent. At this point, you'll want to assign a value of stop to the page underscore URL variable, signaling the end of available data. By setting up a filter, you can ensure that only those bundles with a page underscore URL that hasn't reached stop are processed further. This prevents unnecessary operations and optimizes your workflow by focusing only on bundles that contain data. Implementing this strategy means you're effectively managing operations and saving crucial time and resources. In this scenario, we'll walk through the process of using an API to collect images from a location. We start by making a call to the Pexel API. It's important to note that this API uses pagination, which means we need to handle multiple pages of data. To do this effectively, we use a repeater. The repeater allows us to make repeated API calls using the next underscore URL value provided by the API to move through pages. This ensures we gather all available data. Once we've collected the images, they are saved into a Google Sheet for easy access and management. Additionally, a tool is used to set multiple variables. This step is crucial as it initializes the page underscore URL variable based on the guidelines in the documentation. By setting these parameters, we ensure our process runs smoothly and data is accurately retrieved and stored. In this scenario, you're interacting with the Pexel API to gather images based on a specific location. Because the API uses pagination to handle large sets of data, you'll need a way to make multiple requests to get everything. This is where the repeater comes into play. Think of the repeater as a tool that automates repeated tasks. It's programmed to keep calling the API until all the data is retrieved, using a special variable called next underscore URL to guide each step. Setting the repeater to a high number of repeats ensures you don't miss any images, but it also requires a balance to avoid overloading with too many pages. Finally, once all the images are gathered, they're neatly organized and saved into a Google Sheet. This method streamlines your data collection and storage, making the process efficient and scalable. Imagine you're tasked with gathering a comprehensive collection of images from a specific location. This scenario involves using the Pexel API to call and retrieve these images efficiently. Since APIs often use pagination to manage large volumes of data, we utilize a tool called a repeater. The repeater allows us to automate multiple API calls, ensuring we gather all available images by utilizing the next underscore URL for seamless data retrieval. After collecting the images, they are systematically saved into a Google Sheet. This organization makes it simple to manage and analyze the data later on. An important step in our process is using a module to retrieve the page underscore URL variable. This variable is crucial as it drives the HTTP call that fetches even more images, ensuring the whole collection is as complete as possible. This method optimizes both time and resources in large-scale data gathering. In this scenario, we're focusing on making effective use of the Pexel API to gather images efficiently. The key is understanding how pagination and HTTP requests integrate to streamline this process. First, you initiate an API call to Pexels, which acts like a request to a server asking for specific image data based on location. The API is structured with pagination, meaning it delivers data in chunks or pages. To capture all the data, a repeater is used. This tool automates the repeated API calls using the next underscore URL to ensure you don't miss any image. Each image fetched is then neatly saved into a Google Sheet. This not only organizes the data, but makes it readily accessible for review or further processing. The crucial step here involves the HTTP make an API key auth request module. This component carries out the API call by authenticating with Pexels using an API key. It relies on the page underscore URL obtained earlier, which guides it through each set of images. Before executing the HTTP module, a filter is added. This filter is essential because it halts any further requests once all pages of data have been processed, ensuring efficiency and preventing unnecessary calls, which could consume excess resources or time. By understanding these steps, you can seamlessly integrate APIs to manage and store data effectively, providing a robust solution for gathering media content. In this scenario, we're using the Pexel API to gather images from a specified location. Our goal is to efficiently collect all available data, and we achieve this using pagination. Because the API supports pagination, we utilize a feature called the repeater. This allows us to automatically repeat API calls and keep gathering data by using the next underscore URL value provided by each response. Once we've accumulated the data, we need a way to organize and store it. Here, Google Sheets comes into play, offering a convenient space to save these images. A key component of this process is updating the page underscore URL variable. We use a tool to set multiple variables, ensuring that with every API call, the page underscore URL is updated with the next page's URL. This seamless transition between pages ensures that you won't miss any information as you pull in images. By automating these steps, you convert complex data retrieval into a streamlined workflow, making it easy to handle large sets of images efficiently. In this scenario, we're leveraging the Pexel API to access images of a specific location. The process begins by making an initial API call. Because the Pexel API uses pagination to manage data, it doesn't deliver all images at once. Instead, we use a repeater to make multiple calls. This ensures we gather all available images by continuously updating with the next URL provided by the API. After retrieving the images, they're organized as an array. Here, the iterator plays a crucial role. It breaks down the array into individual units or bundles. This separation is essential as it enables us to process each image independently, facilitating smoother data handling and organization. Finally, all these images are neatly stored in a Google Sheet. This not only centralizes the data for easy access and review, but also ensures that the images and their URLs are saved in a structured manner for future use. By following this workflow, you're able to efficiently handle image data from external sources and store it systematically. In this scenario, we dive into the process of using an API call to the Pexel API, which helps us gather images of specific locations. Imagine wanting a collection of beautiful cityscapes or natural landscapes. This API fetches those images directly. Since the API uses pagination to manage large sets of data efficiently, we employ a repeater. This tool is essential as it allows us to keep calling the API until we've retrieved all available images, utilizing each subsequent page's URL to do so. Once we've gathered the images, the next step involves organizing and storing this data systematically. Here we bring Google Sheets into play. The images, along with their URLs, are input into a Google Sheet. This creates a centralized and easily accessible repository for the visual information. Not only does this method streamline data management, but it also provides a clear overview of everything in one location. This setup is especially useful for subsequent tasks like data analysis or report generation. So essentially, from API calls to a structured spreadsheet, this scenario illustrates a seamless workflow for handling image data. Before we dive into building your scenario, let's make sure you have everything set up properly. You'll begin by organizing your Google spreadsheet, which will serve as the central location for your image data. Use the Google Sheet you created in the previous unit named max03_u02. This way you have a consistent framework to store and manage your information. Next, add a new sheet within this document and call it exercise_3. It's important to name your columns clearly to keep things organized. Start by labeling the first column as image URL and the second as image description. This setup will help you efficiently catalog the images and their details. Don't forget to copy and paste the header information into cell A1. This step ensures that your sheet is ready for data entry, maintaining clarity and consistency throughout your process. Once these preparations are complete, you're all set to start building the scenario. Let's dive into setting up the foundation of your scenario. Start by creating a new scenario in Make and name it MA_C03_U03. This unique identifier helps keep your projects organized. Next, introduce a variable to store the initial page URL. Name this variable page_URL. You'll find the URL you need detailed in your documentation. Simply copy it and paste it into the variable value field. Once you've done this, remember to click OK to save your progress. For clarity, let's rename the module where this variable is stored. Right-click on the module, choose the Rename option, and label it Initial URL. This naming convention makes it easier to identify what each component does, especially as your scenario becomes more complex. These steps are all about setting up a solid structure that will streamline your workflow later on. Now that you've set up the initial URL, let's move on by adding a repeater module from the flow control section. This module is crucial because it allows you to generate as many bundles as needed to pull all your data from various pages. Think of it as a loop that helps automate repetitive tasks. We're setting the initial value to 1 and we'll be repeating this task 40 times. This means you'll use 40 operations. But if you're looking to conserve resources, you can reduce this number to 10. While a higher repeat count can increase the data you retrieve, always balance it with the available operations. By clicking OK, you're saving these settings and preparing the next step in your scenario. This structured approach ensures your data retrieval process is robust and efficient. In this step, we're using the repeater module to create multiple bundles of data. Imagine it as a loop that runs 40 times, generating bundles that act like data packets. Each bundle contains a sequential number, starting with 1 and going up to 40. This repetitive process ensures that you have enough data bundles to cover various segments of your project. Now, you might wonder why we're generating so many bundles. In this scenario, the primary goal is to make sure you can retrieve all necessary information, even if your needs expand in the future. Though we're setting the repetition to 40 here, remember that you can adjust this number to fit your operational constraints. Currently, each bundle includes an index value, but it's not essential for defining page numbers in this context, unlike previous steps. This setup is more about preparation and ensuring your scenario can efficiently handle data retrieval as intended. As you build the scenario, focus on understanding how these bundles will integrate and support the overall functionality without needing to run it just yet. Now that we've set up repeated bundles, let's dive into the next step, retrieving data using the proper tools. First, you'll want to add a module designed to get multiple variables. This is crucial for interacting with the data structures we've been working with. Once you've added this module, it's important to create a variable to capture the data. Specifically, you'll type page_URL. This allows us to pull the specific web address information stored from earlier steps using the variable we previously established. For clarity and organization, let's rename the module. This step helps keep your workflow neat and ensures that anyone reviewing this scenario can easily understand what each part does. Right-click on the module, select Rename, and enter Get Page_URL. Then confirm with OK. With these actions, we've seamlessly integrated a structure for efficiently retrieving our targeted data. As we continue building the scenario, we're focusing on the operation within our module. Currently, this module is triggered 40 times, one for each bundle generated by the repeater. Each activation outputs the value of the page_URL variable. It's important to note that the page_URL variable hasn't been updated yet. This means that across all these activations, the URL remains the same as the initial starting point. Understanding this behavior is crucial because it sets the foundation for how data will be handled and manipulated as we proceed. To begin building your scenario, you'll need to integrate an HTTP module that makes an authenticated API request. Start by adding the HTTP module and selecting the Pexels connection you set up earlier. This connection allows you to authenticate your requests using an API key, ensuring secure data retrieval. Remember to adhere to established best practices for using the HTTP module. This includes confirming that your connection settings and security configurations are correct to avoid any issues down the line. In the URL field, map the page_URL from the Tools module. This step is crucial because it allows the HTTP request to pull the correct data from your designated starting point. Ensure that the HTTP method remains set to GET, which is the default option for retrieving data from an external source. By setting up these components carefully, you're laying the groundwork for a smooth and efficient data retrieval process. Now let's focus on enhancing your API query by adding specific parameters. The parameter you'll add is called query. This is how you specify what you're searching for, like when you type keywords into a search engine. Here, we're looking for images of Kilimanjaro on Pexels, so Kilimanjaro becomes the value for your query parameter. The per_page parameter controls how many results you get per page, but it's optional. If you leave it out, the Pexels API defaults to showing 15 results per page, which works perfectly for our needs right now. Once you have your parameters set, make sure to save your work. This step is crucial as it ensures that your setup is correctly configured and ready to run. With everything in place, you can execute the scenario and begin retrieving those stunning images of Mount Kilimanjaro. Now let's delve into the output of our operation. The status code 200 indicates that our API request was successful. This input-output process generates a collection of data associated with our query for Kilimanjaro. Here we're retrieving the first 15 photos out of a total of 39 results. Notice the URL for the next page. This is crucial for navigating through subsequent pages of data. Currently, the module continuously retrieves the same page because the page_URL hasn't been updated yet. This setup is intentional and serves as a stepping stone for our next operation. It lays the groundwork for dynamically accessing all available pages, ensuring comprehensive data retrieval throughout the scenario building process. To proceed with building your scenario after making the API call, you'll need to capture the value of the next page URL from the API response. This is essential as it allows you to iteratively access subsequent pages of data, moving past just the first page. The first step involves adding a module designed to set multiple variables. This will help you manage and update the information efficiently. Once the module is in place, right-click on it and select the option to rename. Name it Next Page and confirm the change by clicking OK. This renaming step is crucial for keeping your workspace organized and ensuring clarity as you proceed. Next, open the module to insert a new item where you'll define the variable name. Ensure to enter page_URL accurately. Double check that the spelling matches exactly with the existing variable name, as any discrepancies in capitalization or spacing can lead to the creation of a different variable instead. This can cause issues later on, as the getVariable module will not recognize the incorrectly named variable, disrupting the data retrieval process. By paying attention to these details, you set up a robust mechanism to handle pagination seamlessly. Now that you've set up the API call, it's time to define the variable value to manage page progression effectively. If a next_page URL is provided, you need to update the page_URL variable with this value. This ensures that your scenario continues to load the subsequent page. However, when the next_page is absent, indicating the end of the results, you'll assign the value stop to the page_URL variable. This prevents unnecessary attempts to load pages beyond the available content. To achieve this logic seamlessly, use the ifEmpty function. This handy tool checks if a value is empty. If next_page has data, it retains that URL. If it doesn't, ifEmpty defaults to stop, halting the process. By using this function, you effortlessly manage the flow of data retrieval. To continue building the scenario, let's focus on ensuring your page navigation works smoothly. We're checking the next_page item from the HTTP module to see if there are more pages to load. If a next_page is available, the function should return its value and store it in the page_URL variable. This enables seamless loading of subsequent pages. However, when there are no more pages, the next_page will be empty. In this case, we need to assign the value stop to page_URL. This signals the end of page loading. The function you'll use is ifEmpty nextPageStop. This function checks if next_page is empty and returns stop if so, preventing unnecessary actions. Ensure you map the next_page element correctly from the HTTP module when entering it in the variable value. Once that's done, remember to click OK to save your setup. This setup helps manage the flow effectively, ensuring your process stops at the right time, keeping everything efficient. In this scenario, we are ensuring that our bundles transition smoothly between modules. The key here is to allow bundles to proceed to the HTTP module only when the URL does not contain the term stop. To manage this, we'll set up a filter between the getPage_URL and the HTTP module. First, click on the link between these two modules and assign a name to the filter, such as Next Page Available. This naming helps keep our setup organized and easy to follow. Now let's define the condition for this filter. You'll need to map the page_URL variable coming from the getPage_URL module. This variable represents the current URL that we're evaluating. Next, select a text operator to set our condition. Choose Not Equal To from the drop-down menu, and in the corresponding field, type Stop. This condition ensures that only URLs that do not contain stop will pass through the filter. Finally, click OK to save your filter settings. By setting up this filter, we're effectively controlling the flow of data, which helps maintain an efficient process and prevents unnecessary requests to the server. With the API call set up, you're ready for the next step in building your scenario. This involves handling each image URL individually, and for that, you'll need to use an iterator. An iterator allows you to take a collective array, in this case, the data photos, from your HTTP module and split it into individual elements. Each image URL will be processed separately, creating a new bundle for each. This is particularly useful when you need to perform specific actions on each image, such as resizing or tagging. By isolating each URL, you have more control and flexibility over how each one is handled in your process. This setup ensures that your workflow can efficiently operate on a large set of images step by step without missing any details. After setting up the API call, you'll notice that the iterator module has successfully processed your data, resulting in 3 separate bundles. Imagine you have a collection of 38 images distributed over multiple pages. The iterator helps by organizing these images efficiently. The first 2 bundles each include 15 image URLs, while the last bundle contains the remaining 8. This method ensures each image is handled individually, facilitating easier management and further processing. Keep in mind that these numbers might vary in your case as images can be added or removed over time. This approach provides flexibility and ensures your scenario can adapt to changes in the dataset seamlessly. Now that you've set up the API call, let's continue building your scenario. First, you need to add a module to save all images directly to a Google Sheet. Start by incorporating the Add a Row module into your workflow. Make sure to connect it to your Google account. Then select the Mac03 underscore U02 spreadsheet you created earlier. Once in the spreadsheet, find the sheet named exercise underscore 3. Next, map the data from the iterator. In column A, labeled Image URL, you should place the SRC original item, which contains the unique image URL. For column B, the image description, use the alt item from the iterator to provide a brief description of each image. With these connections mapped, save the module by clicking OK. Finally, run the scenario. When you check your spreadsheet, you'll see it's now filled with all your data, showcasing each image and its description. This step-by-step process ensures that your spreadsheet is organized and comprehensive. Now that you've successfully set up the API call, let's delve into what happens next. You have a total of 38 bundles, each representing an image. These bundles will be systematically processed by the Add a Row module. What this means is that for each bundle, a new line will be added to your Google Sheet, resulting in 38 new entries. It's important to note that the number of bundles may vary, as new images could be added or existing ones removed over time. This flexibility ensures that the process can adapt to changes in your data set without requiring major adjustments. By following this procedure, your Google Sheet will dynamically update, reflecting the most current data available, making your workflow efficient and up to date. Keep in mind that this step is crucial for maintaining organized and accessible data records. In this pro tip, we're exploring a strategic method to control when your scenario stops processing. This is particularly useful for scenarios that pull data from paginated APIs. The key is to leverage what we call a commit error handler, which effectively halts the processing once the data hits the endpoint. Here's how it works. You set up your scenario to recognize when it's reached the last page of data. When there are no further pages to fetch, you direct the process to a route where it intentionally tries to access a non-existent URL. This action generates an error, allowing the commit error handler to come into play and stop the scenario from moving forward. A crucial part of this approach is ensuring the repeater module doesn't attempt to create empty bundles. Creating a route for the first bundle that lacks a next page parameter ensures that your process halts gracefully, preventing unnecessary operations. This technique is seamless, effective, and keeps your scenario from expending resources beyond its necessity. By harnessing these methods, you're optimizing workflow efficiency and data management tasks. In this pro tip, we'll explore setting up a filter and leveraging flow control to optimize the routing of data bundles. This approach is particularly useful when dealing with paginated APIs. Imagine you have data bundles flowing through a scenario. You want to ensure they're directed correctly based on whether there's more data to fetch. Here's how you can manage that. First, set up a fallback route. This acts as a safety net, capturing any data that hasn't been processed by other routes. Essentially, if the data source doesn't fit into any existing paths, it defaults here. If your data bundle includes a next page URL, it means there's more data to gather. In this case, the bundle travels through the primary route where additional information is collected and processed, say, into a spreadsheet. But if there's no next page URL, it signifies the end of available data. Here, the bundle takes the second route, intentionally leading to an error. This error serves a purpose. It effectively stops the scenario, preventing unnecessary processing. By setting up this filter and fallback mechanism, you're able to streamline the data flow, handle end-of-data situations gracefully, and maintain efficient processes within your scenarios. In this use case pro tip, we're looking at how you can intentionally generate an error to help manage your scenario's flow effectively. When working with HTTP requests, it's important to understand how certain response states can be leveraged to control your automation. Here, any HTTP status outside of the 2XX and 3XX success codes is evaluated as an error. Imagine you want to halt the processing when there's no more data to fetch. By deliberately calling a non-existent URL, you force an error condition. This error isn't a mishap, it's a strategic pause. It signals the system to stop further processing, preventing unnecessary requests and saving resources. In this case, we're using the method get and a placeholder URL structure to trigger this error. The wisdom here is in using errors not as glitches to be debugged, but as tools you can harness to enhance the efficiency of your workflow. In the following module, we'll see how this error is managed, ensuring that your scenario stops gracefully without unwanted operations. In this module, we're discussing a practical tip for handling errors in HTTP operations, particularly focusing on flow control and the commit process. Imagine you're running a sequence where data is being fetched and you encounter a situation where the service isn't reachable. This results in a connection error. The commit error handler plays a crucial role here. It ensures that when an error appears, the scenario halts immediately, preventing any unnecessary actions that would follow. For instance, if the next page URL is found to be empty, the commit step stops the execution right there. This is particularly useful to avoid the generation of unnecessary data bundles by a repeater function. By using this approach, you effectively manage resources and streamline your process as it stops the run at the right time, allowing you to handle data processing more efficiently. In this unit, we've explored the concept of variables and their pivotal role in managing data within a scenario. Think of variables like boxes with unique labels that store data for you. They're essential for tasks like making API calls, where a single variable might be used to hold the URL for each page request. Now, if you ever face a situation where you can't determine how many repetitions are necessary, setting a high limit can be a practical solution. This ensures you gather all required pages without overwhelming the system. Plus, a smart workaround can help you stop processing any empty bundles that might crop up. Each time you initiate a scenario, you'll assign the initial URL to your variable using the set variable module. As you progress, the get variable module retrieves and updates this value, allowing your process to remain dynamic and responsive. This efficient handling of variables keeps your operation smooth and effective within a specific route, maintaining a clean and organized flow. Congratulations on completing this unit. You've gained a solid understanding of how variables work, how they can be set, updated, and retrieved within scenarios. This is a key skill when working with dynamic data. You've also learned to handle paginated data without a predefined total item count. This is incredibly useful because it allows you to efficiently process large data sets in manageable chunks, even when the endpoint doesn't indicate the size of the data. Another critical takeaway is how to circumvent issues caused by processing empty bundles, particularly when using repeaters. By implementing these workarounds, you prevent unnecessary operations, streamlining your data processing. With these concepts in mind, you're well prepared to dive into the next unit, where we'll explore another facet of pagination. Well done and keep the momentum going.